The next question on the books to answer is that we have 10 cosine of x equals 5 cosine 5 square root of 3, and said what happened to the x in 5 square root of 3. But if I look at what you have handwritten, it says find all x values where the tangent line to the graph of f of x equals 10 sine of x plus 2/5 is parallel to the line y equals 5 square root of 3x equals 8/5. Now, one thing I need to caution you, and this is why I put this one on here, you got to be really careful because I suspect that this is 5 square root of 3 times x, but what you have written is 5 times the square root of 3x, so those are two totally different things. Okay? Now, I suspect it's this top one because it should have been a linear equation if it's talking about it being parallel to the line, this. Okay? So if you look at the equation for a line, then if we start off with this, I mean, think about it. You can write it in slope-intercept form if you'd like. You can add 5 squared to 3x to both sides. And what's that going to leave us with? We're going to get y equals 5 squared to 3x plus 8/5. Now that's in slope-intercept form, so the number in front of x, its coefficient, is the slope. So the slope equals 5 squared to 3. Okay, so where is the tangent line of that graph equal to that? Okay. So what we want then is, what is the derivative? Because the derivative tells us the slope at any point on that graph, right? So if f of x is 10 sine of x plus 2/5, then f prime of x is 10 cosine of x. It's supposed to be a 10. Now we want to know, where is that equal to 5 square root of 3? So when is 10 cosine of x equal to 5 square root of 3? We could divide both sides by 10. Then cosine of x is going to be square root of 3 over 2. Because we're just dividing this by 10, dividing that by 10, and we reduce our little fraction. So where is cosine of x equal to the square root of 3 over 2? Now, one thing I would suggest is knowing some of these things, and you can think about a unit circle. If you don't know that one yet, you probably should. Now, I always just think about the first quadrant because you'll see these angles quite often. So first one, and I'm going to write these in radians, is pi over 6, pi over 4, and so that's 30-degree angle, 45-degree angle, 60-degree angle would be, like pi over 3, pi over 2, and each of these has an ordered pair associated with them, and then there's, of course, the 0, and that point on the unit circle is 1, 0. Now I'll show you a little trick of how I fill these things in. This point at pi over 2 is 0, 1. Now, every ordered pair has a denominator of 2. Okay. Now, the numerators are always square roots of something. Okay. And then all I got to do is fill in. Now, with the x-coordinates, I start at 0, and you just work your way up from 0, counting up. 1, 2, 3. Okay? And then for the y-coordinates, starting at 0, go 1, 2, 3. Okay? Now the square root of 1, of course, is just 1, so I could get rid of that square root. And this one down here as well. So cosine is always the x-coordinate. Okay? Cosine is x-coordinate. And then sine is the y-coordinate. So looking, when is the x-coordinate square root of 3 over 2? That would be right here. Now, since it's the x-coordinate, we have a little bit of symmetry and stuff involved. It's also going to occur at this angle down here, because that's going to be square root of 3 over 2 and negative 1/2. And those are the two spots where we're going to get that. Now, what is that angle? That would be well, the easiest one to write would be negative pi over 6. Okay. Or 5 pi over 6. Okay. Whichever one you want to write it at, really. So, it says find all values. Okay. Now, you didn't give me any kind of range for the intervals or not. So, if you look at this first one, if we start off at this angle, and that's at pi over 6, we could go all the way around the unit circle, wind up back there, and have exactly the same thing. So what that means is we're going to have, not square root 3 over 2, because cosine of x, we're looking at the angle, that would be pi over 6 plus 2 pi k, where k is any integer. And that just tells you how many times you go around the circle. Whether you go around clockwise or counterclockwise doesn't matter because we were using the integers there. Now there's also the other one, or it's a negative pi over 6 plus 2 pi k, for k being an integer as well, because you could be starting at this point, going around the circle again, going around the circle again. Remember, k is just really how many times we go around the circle. So that would be all of the points, but the question of what happened to the x, I honestly think you wrote it down wrong. Okay. And that x was not supposed to be under the square root. But I figured, let's go ahead and do this whole problem. So, if you have any more questions on it, please don't hesitate to ask.